Hello, Bacha Party. Today we are going to start about the first chapter of chemistry, that is chemical reactions and equations of science, 10th standard NCERT CBSE board. I would also like if you like, share and subscribe to this video where the chapter is chemical reactions and equations. In this chapter we'll come to know about various different materials and objects covered, like physical change, chemical change, types of reactions, chemical reactions, balancing the equations, corrosion, rancidity, and many more. Physical change. Now, do you know what is a physical change? Physical change means new substance is not being formed, only its change in state, size, and shape takes place. These reactions can be reversible as well, like examples: breaking of glass, melting of ice, and many more. We also see different types of physical changes and chemical changes in our day to day life. Chemical changes, a change in which new substance, it can be one or more than one, has been formed, which has different physical and chemical properties, like burning of wood, rusting of iron, and many more. Chemical reactions. Now, what are these reactions? These reactions are having new chemical properties after a new substance forms, like when hydrogen and oxygen they combine, a whole molecule water is formed. Similarly, when magnesium and oxygen reacts, magnesium oxide white color powder is formed, water in liquid state. Different types of chemical reactions, word equation and chemical equation. Two ways to represent them. Word equation includes carbon plus oxygen gives carbon dioxide, that is using their word form. On the other hand, chemical equation means using the symbols to represent, like carbon stands for C, oxygen for O2, which forms carbon dioxide, that is CO2. What are reactants and products? In a chemical reaction, there are two parts, reactants and products. Reactant basically indicates the substance which undergo chemical reaction. On the other hand, the product formed after the reaction will indicate about the formation of a new substance. These reactions are mostly irreversible. Some of them are also reversible. Example, when magnesium and oxygen combine to form magnesium oxide. So magnesium and oxygen here are the reactant because they are undergoing chemical reaction. Magnesium oxide is the product which is formed as a new substance with new physical chemical properties. Now we come to know from this activity about chemical reactions in detail. Chemical reaction means a new substance is formed. So this we have to take a magnesium ribbon, clean it with sandpaper to remove the oxide layer which is formed on it before, as it is a bit highly reactive. So so magnesium ribbon after cleaning need to be heated. After it is burned, the oxide is formed, that is white in color. You can collect it in the watch glass. The observation is magnesium ribbon will burn with a dazzling white flame, and a white powder of magnesium oxide is formed, which is magnesium oxide, that is white powder. It forms due to reaction between magnesium and oxygen. We can know about different characteristics of chemical reaction, that is formation of precipitate, evolution of gas, change in physical state, change in odor, color, or temperature. In temperature, there are two ways, like absorption of heat or release of heat. So, absorption of heat will come under endothermic reaction, while removal of heat comes under exothermic reaction. Chemical equation. What are chemical equation? Basically, we know few things about chemical equation from our past slides. That means representing word equation in the form of their chemical chemical structure, that is hydrogen representing by H, oxygen representing by O, O2 and H2. So it forms water. We came to know about this before also. That means a shorthand representation of a chemical reaction using symbols and formulae of elements and compounds is known as chemical equation. There are two types of chemical equation: skeletal equation and balanced equation. Skeletal equation basically means the equation in for which we don't know their number of atoms. We know the number of atoms on both reactant and product side, but which they are not in equal number. So we say them as skeletal equations. For example, we take the example of again same magnesium and oxygen forms magnesium oxide. Here the number of atoms for oxygen is 2, while on the product side it is only 1. So it is a skeletal equation, which is also known as unbalanced chemical equation. Now we come to know about balanced equation or balanced chemical equation, which means the number of atoms on both reactant side are equal to the number of atoms on the product side. In the example we took before was Mg plus O2 will give MgO2, that is magnesium plus oxygen gives magnesium oxide. Here to balance we had oxygen, two atoms for oxygen on the reactant side, while only one atom of oxygen on the product side. So to obey the and also to obey the law of conservation of mass, we add a 2 in front of magnesium oxide. So here the number of atoms for magnesium and oxygen are 2. On the reactant side we have 1 magnesium and 2 oxygen. So oxygen got balanced. To balance magnesium we again add a 2 on the reactant side. Now the chemical equation is said to be balanced chemical equation. For balancing a chemical equation, we undergo certain steps. So, we'll come to know about these steps one by one. First, we need to consider a chemical equation. Draw a box around each and every element or compound. Second step, draw. We have to make a table, and in which we have to make three columns. That is for element, the reactant, number of atoms on the reactant side or the LHS side, and number of reactant on the product side. Later we have to write all the elements, that is for the following reaction we have iron, hydrogen and oxygen. So the number of atoms for hydrogen and oxygen are 2 and 1. For iron also 1, that is Fe. While on the product side, for iron we have 3 atoms, for oxygen we have 4, and for hydrogen we have 2. So we can see that the equation is unbalanced. So we move on to our third step, that is starting with our balancing. First we start to balance hydrogen. So to balance we multiply by 4 on the reactant side, as we had 4 oxygen in the product side. So we add a 4 in front of hydrogen, that is water, that is H2O, to balance oxygen. We This process is known as the first step of balancing. The equation now can be known as partly balanced equation. If a person writes H2O and adds a 4 below oxygen, which is the wrong step. So that should be considered as wrong. So we always add the number of atoms after balancing in front of the equation, that is outside the box. Yeah. Later on, we balance the next element, that is iron. We had 3 in the product side and 1 in the reactant side. So we multiply the equation, the iron, with 3. That is 1 and 3. So we add a 3 in front of iron. The equation is now partly balanced. Now we can come next step is to balance hydrogen. We have 2 hydrogen on the product side and 8 hydrogens, that is 4 and 2, which makes 8 in the LHS side or the reactant side. So we multiply in 4 on the product side. So that gives 4 and 2, 8. 4 into 2, 8. Now we compare that all the elements are balanced. So we can see 3Fe and 3Fe are both on the reactant as well as product side. 8, 8 hydrogen on both the sides, reactant and product. Similarly, 4 oxygen is there present on both the sides, reactant and product. Now we can say that the equation is balanced. Final step which undergoes is to write the symbols of physical states for the following equation. That is, iron is in solid state, water in gaseous state, iron oxide, that is Fe2O3, ferric oxide, in solid state, and finally hydrogen gas, which is excreta or the end product which is liberating outside as a gaseous form in the gaseous.